Hi, I'm Colin Walls, and I'm here today, as usual, to talk about embedded software. Specifically today, I want to talk about memory in embedded systems. Now I can hear you say, memory is not software, that's hardware. What are you talking about? Well, it's true, memory is hardware, but memory systems are very important. Their architecture is very important to embedded software engineers. So that's what I'm going to talk about today, to consider what memory looks like in an embedded system. Now, there are different kinds of memory. If we look back in time to embedded systems just a few years ago, the typical architecture had two kinds of memory. The first was read-only memory, ROM. This is memory which contains data which does not go away when it's powered down, so it's still there next time you turn it on, and you can't change it. It's read-only. We used a special kind of read-only memory called programmable read-only memory, PROM. Now, PROM chips, you would program them with the data you wanted, and then you could use them and they couldn't change unless you chose to erase them, which was normally done using a UV light. Then you could program them with some different data. The other kind of memory in a system would be RAM, random access memory. I've never understood why it's called random access memory, because RAM is memory which is read-write. You can write the memory on the fly. It contains garbage when you start the system up, but when you put data in there, it stays there for as long as you apply power. The reason I question the name is random access memory. Well, ROM is random access as well, so the name is rather stupid. We should call it RWM or something like that, read-write memory. But anyway, it's called RAM, and that's what we have. So in those days, you will put the code and the data, and that's the read-only data, into the PROM, and then you would keep all your working data, the changeable stuff, in RAM, remembering that RAM needs to be initialized because it starts off containing garbage. And that worked fine. The code could execute out of ROM and find its data in RAM. Nowadays, however, most systems tend to have flash memory instead. Now, flash memory is a bit like ROM in that it keeps the data, it keeps its contents through a power down, but it has the advantage that it can be dynamically programmed on the fly if you want to update it. This means that field updatable embedded systems make more sense. The downside of flash is though you could execute code out of it, the access time is quite slow and not fast enough to keep up with modern CPUs. So what's normally done is the flash memory content is copied into RAM and the entire program executed out of RAM. So we end up with the RAM containing our code, our read-only data, and our read-write data. The use of RAM this way has two drawbacks. It has the advantage it works. But the two drawbacks is there's a startup delay while you copy the data from flash to RAM. Now, depending how big the system is, how big that delay is. So it may or may not be a big deal. The other issue is one that concerns me a bit more, and that's security. Because once the code is in the RAM, it could be changed. And in other words, a software error could corrupt the code, it could corrupt the constant data. Worse still, I suppose, a bad person could find a way into your system and change the code and change the data in RAM. In an old-fashioned embedded system, there's no way they could affect the contents of the PROMs, even if they could corrupt the RAM data. They can do a lot more damage with a modern system, if it's not designed right. So security is a big issue, so I'm not going to cover that today, but it becomes more important when we're executing code out of RAM. Many, many years ago, real computers, i.e. the kinds of things that filled rooms, they used a kind of memory called core memory. Now, core memory came in slabs about this big and contained very little data by modern standards, and it was heavy, it was power, it used loads of power, and it had a big advantage though, is that it didn't forget between power-ups and power-downs. You could make it forget by dropping it, actually. It was quite interesting. It would be very nice to have memory that had those characteristics again. So memory where it just remembers what's in its contents from one execution to another. That way we could initialize a system, power it down and power it up, and the data and code will be ready to go. So we can't do that currently because we're busy copying from flash to RAM. There are a few technologies around that are heading in this direction. One of them is magneto-resistive random access memory, MRAM. I'm wondering if that will be suitable in time to come. This memory has the ability to be persistent and it's fast enough to execute code from. So we'll see. It's available on the market now, I believe, in at least small quantities, so it'll be interesting whether that becomes more significant in the course of this coming year. So let me know if you know about MRAM or you know other technologies that address this, and it's probably a subject I'll return to in the future. But for now, that's it for this video. I will be here again soon with another embedded software subject. Bye for now.